So at this point, you should be pretty familiar with Pythagorean Theorem and what it is and what's A and what's B and what's C. So now we're going to look at what exactly is a Pythagorean triple, and you should have actually just finished a lab where you discovered a bunch of your Pythagorean triples, and you'll be asked to put those on your notes down here towards the bottom. So it says, you previously learned that when two sides of a right triangle are known, then the third side can be found using the Pythagorean theorem, and that any group of three positive integers where a squared plus b squared equals c squared, this is called a Pythagorean triple. So it's a special set of numbers. So if they give you a set of numbers, like on example 1, and they ask you, is this a Pythagorean triple? The first thing you have to figure out is which ones would be a, b, and c. Because remember, we have a squared plus b squared, and that should equal my c squared. So in order to see if it is a Pythagorean triple, we have to plug it in. But that we need to know which one is which. So we talked about how the largest side is opposite the largest angle. So C should always be the largest side. So the largest number here is 5. So that would be my C value. These two would end up being my A and B. So if they write them in order, C will always be the one farthest to the right because it should be the biggest. But if they don't, make sure you know C will always be the biggest number. So now if we plug them in, this would be 3 squared plus 4 squared, and that's supposed to equal 5 squared. So now we just need to see if it's true. 3 squared is 9, 4 squared is 16, 5 squared is 25. So if I add 9 plus 16, I do get 25. So 25 does equal 25. Therefore, we would say, yes, this is a Pythagorean triple. So now it says name some of the other Pythagorean triples that you did in your lab. So you can either get your lab or write these down before you move on. And then some other piece of information that we needed to recall, just in case you don't remember. Back in the day, you guys did a lab with straws where you had to try to make a triangle. And it said that a triangle can be formed only if. So we said that the sum of the smaller two sides Can you pat Nova while you're walking by there and wake his butt up? He keeps snoring. Has to be greater than the third side or the larger side. So this is where if we have the two sides, that A plus B has to be greater than C in order for a triangle to be made. If this isn't true, then we don't even have a triangle. So let's look at the bottom and kind of practice that real fast before we move on. So it says which of the following are the lengths of a triangle. So again, the larger one is going to be this one. We're not checking to see if it's a Pythagorean triple. We're just seeing if this is true. So A plus B has to be greater than C. So if I add, this would be 4 plus 5 has to be greater than 6. So then 4 plus 5 is 9. 9 does happen to be greater than 6, so the answer here would be yes. A triangle can be made. So then, same idea. We've got 4 plus 5 compared to 9. Again, we would have our A plus B has to be greater than C. So you guys work that one out and let me know. And then the same thing here. We have 4, 5, and now 10. So now you see if A plus B is greater than C. So you work those out. Good. So then let's flip it over onto the back and let's see how we can kind of apply this information. Some more information that's coming back to haunt you. Vocabulary, vocabulary, vocabulary. Recall one way to classify a triangle is by angles, and so far we've been working solely with right triangles in this Unit 5. But what if it's not a right triangle? Can we tell by using the sides of the triangles? Absolutely. So a triangle could also be acute, and it can also be obtuse. So if C, the longest side, and A and B are the two shorter sides, which is what we've talked about all the time, and A squared plus B squared equals C squared. This is the standard formula. This is what we've been talking about. So A squared plus B squared equals C squared. Then this is going to be a right triangle. That one you should be familiar with. If the Pythagorean theorem works, then it is a right triangle. So if the longest side, the hypotenuse, and A and B, the legs, now make this happen. So now A squared plus B squared is less than C squared. Okay, so if the two smaller sides, then this is going to be obtuse. So if I add the square of A and the square of B together and it's smaller than the square of C, then this is an obtuse triangle. So now, obviously, that only leaves one left for this. So now, if we do A squared plus B squared, but this turns out to be greater than C squared, then this is going to be an acute triangle. So we're going to kind of put everything together. First, we're going to determine if a triangle can be formed. Then, once we've figured out if it can be formed, then we're going to decide, is it right, obtuse, or acute? So it says determine if a triangle can be formed, and if so, then classify it. So the first thing we need to do is use our A plus B has to be greater than C to see if a triangle can be formed. So first, what are the two smaller sides? Good. 5 and 4. And then the largest side is 12. So if I set this up, I get 5 plus 4 has to be greater than 12. So that is 9 is greater than 12. True or false? Exactly. This is false. So if we can't make a triangle, we can't classify it. No triangle formed. So we can't classify that at all. Good. So now let's go down here and try C, and I'll do C with you. So we're going to do the same thing. Let's set up our A plus B has to be greater than C. And let's pick out the smaller sides. So this is where it gets a little bit hard, but if you're not sure, take the square root of 10. So the square root of 10 comes out to be 3.2. So this is the largest side. So the smallest one is going to be this, and then this is going to be our largest side. So I would have 1 plus 3 has to be greater than the square root of 10. Well, 1 plus 3 is 4, and we took the square root of 10, and it was 3.16, blah, blah, blah. So is 4 greater than 3.16? Yes. So can a triangle be made? Yes. Oh, yeah, sorry, up here I guess I should have circled no. So then if it can be made, we're supposed to classify. So what you want to do now is set it up where you've got your a squared plus your b squared, and then you're just going to put a circle here. We're not going to put an equals, we're not going to put anything, we're going to leave a circle, and then we're going to set that up with c squared. So then a and b we already figured out were 1 and 3, so we've got 1 squared plus 3 squared, and then we're going to compare that, so there's our circle, to root 10 squared. So if I start to simplify, 1 squared, so 1 times 1 is 1, plus 3 squared, or 3 times 3 is 9, and I have to compare that to root 10. Now there's a couple things to notice. If you automatically notice that a square root and a square cancel, then you can just write 10. But if you don't, a lot of you may know that that means we have this twice. So then I can kind of start to simplify still. So 1 plus 9 would have given me 10 on this side. There's our compare. Then the square root of 10 times the square root of 10 would have been the square root of 100. So then I would have 10 compared with the square root of 100, which is 10. So then what goes in here? Is it an equals, a greater than, or a less than? Well, in this case, it's an equals. 10 equals 10. So since that's true, we would classify this as a right triangle. Good. So now you try B and D.